In the previous classes, we were discussing on module 5. In module 5, we have already covered the area and volume. We have determined how to determine the area by different methods, that is by offset method, by mid-ordinate rule, by trapezoidal and Simpson's one-third rule, and by area by coordinates, how to determine it. Then we have seen what is planimeter and how the digital planimeter will work, and we have solved the problems on the planimeter also. Then how to determine the measurement, right, of a volume by trapezoidal and by prismoidal method, that we have already seen in the previous classes. Now we in today's class we will be studying regarding contouring, that like what is contour, right, then what are the methods of contouring and interpolation of contour and contour gradient and the characteristics of contour and uses. So in our today's class we will be concentrating our study on what are contours, what are the characteristics of contours and its uses. Now in the previous classes we have seen how to determine the area and volume. So if the ground is having too much slope, that is either inclination is there, declination is there, how to represent those particular areas diagrammatically, that we can have it by the contouring. Now these contours, say these maps, okay, we call that as a contour map. These contour map, we from these contour maps we can get if the country is having the flat area, right, or if the area is flat, or if it is going to have the hills and valleys, right, or if it is going to have the lakes, or if it is going to have any kind of a water body, that we can get it from these contour maps. We also call it as a topographical map. Okay, the value of a plan or a map is going to be highly enhanced if the relative position of points is represented both horizontally or going to be vertically. Okay, such horizontally and vertically represented maps, we call it as a topographical map. Okay, in a topographical map, both the horizontal as well as the vertical control points are going to be required. Okay, now these points we are going to represent it by either having the shade or hatches, or from the lines or the contour line. Now what is contour, we need to see first. Now the contour line is nothing but it is an imaginary lines on a ground joining the points of equal elevation. I'll repeat it. A contour is an imaginary line on a ground which is going to join the points of equal elevation. Right. Now suppose I will tell you what is a contour. Okay. Now suppose this is an area where you have done the survey by having either theodolite or dumpy level. You have determined whether it is the area is having a slope, or it is going to the flat surface, or it is having the slope, inclination, declination, whatever it is, you have determined it by using the dumpy level or theodolite. Now in this area, now this map is nothing but the contour diagram. This line is nothing but the contour line. Now what these numbers represent is 96, right, 96, 97, okay, 98 or 99. What these numbers represents are, okay, what these numbers represent are, in this area you have, by using theodolite or a dumpy level, you have determined wherever the RL is nothing but the reduced level, wherever the points of 96 RL are going to meet, there you have drawn this particular imaginary line. Wherever in that area 96 RL, wherever it is coming, you have joined it. Then again in the same area you have joined the area RLs of 97. Okay, RL of 97 you have joined it. Then in the same area again, wherever the points of 98 RL where there you are getting, you have joined it. Then again the RL of 99 wherever you are going to get, you have joined it. Now after having the RL of 96, 97, 98, 99, you have joined all those imaginary line wherever you are going to got the points of equal elevation. Now what is your definition of contouring? It is an imaginary line on a ground joining the points of equal elevation. So what we have done, it is an imaginary line which we have drawn of it is an imaginary line which is on a ground joining the points of equal elevation. So wherever equal elevations are there, we have drawn those imaginary lines. Now what this 96, 97, 98, 99, if we want to convert it into if we want to have the nature of the ground, what we are going to do, we are drawing the lines, the cross sections of this, we are going to draw it, and then we will try to draw one diagram. Okay, now here RL96 both are meeting over here. Okay, 96, 96, 97 we have drawn a line, then 97 is higher than 96, so we have marked a point, then we have joined 98. Okay, then we have marked and we have joined, so 99. So this 96 is at a lower elevation than 99, so it represents that it is having the valley. Okay, it is going to have the valley. Okay, so this is how your contour is going to help you in order to determine what kind of a nature of the area is there. This is how the contouring is going to help you. Okay, so this is regarding your contouring line. Suppose if instead of this 96, if 100 was there, 100, 99, 98, then 97. So how would have been your diagram? Your diagram would have been like this, because 99 is at higher elevation, 99 is at a lower elevation. So again 98, then 97. So you would have draw the diagram like this, imaginary line like this. So it represents that it is an hill. So this is how you are going to determine whether from your contouring, whether the given area is having the valley or the hills, or having any kind of a watershed. So this is the introduction regarding your contour maps. Now here, these imaginary lines, we call it as an contour line. We call it as an contour line. And 97 to 98, this difference between the two contour line, we call it as a contour interval. So this is a brief introduction regarding how the contour line is going to help. Okay, then vertical distance between two consecutive is going to be called as the contour interval. The vertical distance, that's what I have shown in the previous paper. I have shown you what is a contour interval. The horizontal distance between the two consecutive contour is known as the horizontal equivalent, and it is going to be dependent on the following. Okay, your contour lines, contour intervals are going to be dependent on the following feature. It depends on nature of the ground, it depends on scale of map, it is going to be dependent on purpose and extent of survey, and then time and expense of a field and office work. Okay, now first we will consider the nature of ground. Now before going to these particular points, I want to tell a certain important aspect, right? If the map scale is too big, it shows where the ground is nearly level. Okay, where it is sloping, where the slopes are steep, and where they are going to be gradual. If the map is too small, it shows that the country is flat. Okay, and the valleys and it is going to have the lakes. Now we will come to the nature of slope. Okay, now here in the nature of the slope, okay, the contour interval depends on whether the country is flat or highly undulated, or as I have told in the previous diagram. A contour interval chosen for a flat ground will be highly unsuitable. If the contour interval on a flat ground, it is going to be highly unsuitable for a undulated ground. For every flat ground, the small interval is necessary. That means for a flat ground, if the ground is flat, the small interval is going to be necessary. If the ground is going to be have more broken or greater contour interval should be taken. If it is going to have the too much elevation difference is there, then we should take the greater contour interval. If it is having the flat areas, then we should take this contour smaller contour interval. If it is having the either two slopes are there, too much slopes are there, then we should take the greater contour interval. Otherwise the contours will come close to each other. Then the nature of scale of map. The contour interval should be inversely proportional to scale. Okay, if the scale is small, then the contour interval should be large. If the scale of your map is, if it is going to be, it should the contour interval should be dependent on the scale of the map. If the contour interval should be inversely proportional to the scale. If the scale is small, then your contour interval should be large. Okay, it should be large. If the scale is large, the contour interval should be the smaller one. So this is how the scale of the map is going to be dependent. Then the purpose and extent of the survey. The contour interval it is going to be largely depends upon the purpose and extent of a survey. Then if the survey is intended for a detailed design or the accurate work calculations, the small contour interval should be taken. Okay, if we want the detailed thing, right, for a design and all, then the smaller contour interval should be taken, so that we are going to get the more accurate result. In case of the location surveys for a lines of communication or for a reservoir or a drainage, where the extent of survey is large, the larger contour interval should be taken. Then we will be discussing on the time and expense of the field work. Okay, if the time available is less, greater contour interval should be taken, as it is understood, because if we take the greater contour interval, our work is going to be get reduced. If the contour interval is small, the greater time it is going to take in the field survey and in plotting the map also. Okay, so this is how your contour interval is going to be dependent on all these factors. Now we will see regarding what are the different characteristics of contour. I hope this particular diagram is understood, because in order to understand the contour, this particular diagram is going to be important. Now we will see what are the different characteristics of contour. Okay, if the two contour lines, these are nothing but the diagrammatic representation of the contour. Okay, if the two contour line of a different elevation cannot cross each other, okay, the contour lines will not meet each other. These are the contour lines, they are not going to meet each other if it is going to present it at a different elevation. Suppose this is 96 RL, 97 RL, then 98 RL. They never coincide with each other, because they are present at a different elevations. Okay, if they did, then the point of intersection would have the two different elevations which is going to be observed. Okay, if however, if the contour line of a different elevation, it is going to be only intersect if there is an, in case of a cliff is there, okay, or a cave is there. If a cliff or a caves are there, then only it is going to, these different points are going to meet each other. In the points of different elevations, okay, the contour line of a different elevation, they cannot meet with each other. Then the contour line of a different elevation can unite the second point. Okay, they can unite to form one line only in case of vertical cliff, that has been already discussed. The contour lines close together indicate there is a steep slope. If the contour lines, if they are very close to each other, then it is going to represent that it is having a steep slope. They indicate if they indicate a gentle slope, right, like this, right, then they are far apart. If they indicate a gentle slope, if they are right, then if they are actually spaced in an uniform, if they are going to have close to each other, they represent that it is going to have the steep slope. If they indicate a gentle slope if they are going to be far apart. Okay, they indicate a gentle slope if they are going to have, there is a far apart from each other. If they are going to be equally spaced, right, if they are going to be uniformly spaced like this, right, then it indicates that, right, then it is going to indicate there is an uniform slope is there. Then a straight line parallel or equally spaced contour represent there is a plane surface. Okay, if I'll repeat this, if there is an the points, the contour lines close to each other, it represents there is a steep slope. If they are having a gentle slope, right, they are going to have the gentle slope. If they are far apart, then if they are equally spaced like this, it is going to represent, it is going to have, if uniform slope is there, then they are going to be if they are equally spaced, then it is uniformly sloped. And if they are going to a series of a parallel and equal spaced line, then it represents that it is going to have the plane surface. So this is how your contour line is going to represent each other. Okay, now there is one more important aspect, right? If the contour line is going to cross each other perpendicularly like this, right, if it is going to cross each other by, if it is going to be perpendicularly, if it is crossing, then it represents that there is an steepest slope is there. If the perpendicular line is going to cross through it, then it represents that there is an steeper slope is there. Okay, a closed contour line with one or more higher one inside represent it is going to have a hill. Okay, it is going to have a hill if it is going to be closely, it is going to be present. Then if a contour line is the contour lines cross a watershed or a ridge at right angles like this, if it is going to cross the line, if it is crossing the ridge, right, at a uniform, at a right angle, then it is going to forms the U-shape curve. Okay, then it is going to represent the concave side of the curve towards the higher point. It represents that there is an watershed or a ridge is there. Now if the contour lines cross a valley line, this is nothing but your valley line, if it is going to cross the valley line at right angles, they form a sharp curves or V-shaped curve. It is with the convex side of the curve towards the higher end. If there is a stream, the contour on the other side or a turning upstream may disappear or they may coincide. So this is how your characteristics of your contour lines are there. Okay, now in the next classes we are going to discuss regarding the different uses of your contour contour maps, then methods of different methods of contouring and their interpolation methods. Okay, this is we will discuss in the next class. So in our today's class we have seen what is contouring, what are the characteristics of the contour line, and how the contour interval are dependent on each other. So this is what we have discussed in today's class. In next class we will see what are its uses, methods of interpolation, and then the methods of contouring. Okay, thank you.